Good day, everyone. So, today we will be presenting our learning task for the subject algorithms and complexity. So, in this activity, we are going to analyze how brute force algorithm works in using, I know, in recovering a digital safe problem that requires a numeric pin. So the purpose of this task is to understand how brute force approach works when the correct combination is unknown and must be identified by trying all the possible number sequences. So brute force algorithm is a resource intensive approach that highlights how we solve problems with no hints or methods available. So this task examines how many pin combinations can be created in different digital lengths and observe how the numbers grows as more digits are added. So uh, in digital lengths, we are talking about the number of digits in a pin combination. So, to this task will examine how the number of possible pin combination increases as the digit length grows. So, as more digits added, the total number of combination increases significantly, which directly affects the algorithm's running time. So, to support our analysis for this one, we develop a Python program that generates all possible combination based on a user-defined digit length. So the program has a input user input where we can type how many digits are we going to generate for a pin combination. So we then performed some test runs to measure the execution time and observe how this how brute force algorithm performance change as the input size increases. So through this presentation, we will discuss the time complexity of the brute force algorithm. We also evaluate its efficiency and explain its limitations. So, this analysis will help us understand how algorithm complexity impacts performance, especially when handling larger inputs. So, let's start.
Next is I'll be explaining how our Python program works and how it generates all possible pin combinations using a brute force approach. So first thing first is we imported the time module here so that we can record the running time for each test cases. So next is we redefine a function called generate pins that accepts one parameter called num digits. This parameter represents our input n or the number of digits that the pin will have. And inside this function, we created a list called pins and initializes it with an empty string value that and this empty string value will serve as the base for building the pin combinations. Now on this next line, the program will call the function perf counter to measure the program's execution time. Then the function will return a value in fractional seconds so that we can record the time accurately. Now on our algorithm, we used a for loop that runs n times for each digit position. So basically, each for loop or iteration represents one digit position for the pin generation. Then inside this loop, we created a temporary list to hold new pins. Within these nested for loops, the program will go through every existing pin from this pins list, then iterates all digits from 0 to 9, then concatenates each digit to the current existing pins. So to break it down more, since we have initialized a list here with an empty string value. Then that empty string value will be the first value for this first iteration. Then it will now concatenate digits from 0 to 9 to this empty string value. Then that concatenated strings will be appended to the new pins list. So temporarily store it. Then once all pins have been appended, it will now pass the temporary list to the original list. Then start the loop again for another digit position. Once all digit positions are filled, then the program will now record the end time using the perf counter, same as above. Now after this, the program prints the total number of pins generated and the time taken to generate them all. Then at the end of the script, the user is prompted to enter the number of digits for the pin, and then the program calls the generate pins function, then passes the input n to the function. I will now perform some test runs from a small number of digits, since increasing the input size will also increase the running time of the algorithm exponentially. So let's wait first for all test cases to finish. So as we can see here, so from 7 digits, it completed at under 0.7 seconds, while the 8 digits one completed at 9 seconds. This demonstrates that the brute force algorithm grows exponentially. So that's all.
As you can see in the graph above, the algorithm will able to finish generating all possible combinations with digits rather than 2 up to 10 digits in just under 45 minutes. While smaller pin length 2 to 6 digits finish quickly. Generating all combinations for 8 to 10 digits takes much longer, reaching up to thousands of seconds for 10 digits. So, that means we will be able to crack open the safe and still have time left to go back to the airport.
Brute force solution. Brute force is recommended for this type of problem only when the number of digits is small and there is no additional information about the correct pin. Since the safe uses digits from 0 to 9 and the length of the pin is known, generating all possible combinations guarantees that the correct code will eventually be found. The algorithm works by systematically producing every possible pin combination, making the solution complete and reliable because there is no possible option skipped. However, brute force becomes impractical as the number of digits increases. The time and space complexity grows exponentially. This means that every time one digit is added, the total number of combinations increases by a factor of 10. For example, a 4-digit pin results in 10,000 combinations, which is manageable. In contrast, a 9 or 10-digit pin would produce billions of combinations, making the process very slow and requiring a large amount of memory. Therefore, brute force is suitable only for short pins or small search spaces, but it is not recommended for large space problems due to its exponential growth in time and space requirements.